Alright friends, welcome back. In this video we're going to go ahead and talk about the last section from chapter 6 that we're going to discuss, and that is going to talk about all of these multivariable linear systems that we have. So let's take a look at that, right? So a multivariable linear system, that sounds like a big fancy name for something that basically just looks exactly like this, where we have more than one equation that we wish to take a look at the same time, and in these equations there are more than two variables. Typically, we're used to only seeing the variables x and y in our linear equations, but these are going to be examples of ones that actually have three variables in them, okay? And this example that we're looking at right here actually is a really easy example if you were to take a look at it. If you were to try to figure out what all three variables are equal to, just like you would for a linear system with just x and y in it, you're looking at the very end of the day to have a value for x and have a value for y and have a value for z that fits in this system, or that makes each equation true, okay? Well, I want you to look at the system and actually realize how easy this is, because if you look at that third equation, it actually just straight up gives you the value for z, and if you know what z is, then that's something that you could just go ahead and plug in everywhere that you see a z, okay? And so that's going to give us a really easy way to go ahead and work with this, this first equation, because that'll just be 3 times 2, or in other words, that'll just be a 6. And then that makes this 6 right here, okay? So if you were to work with that second equation, that really says y plus 6 is equal to 5, and you would know by subtracting 6 from both sides that actually just is equal to -1. So we have z, we have y now, and there's really nothing else to it but to go ahead and go through here and plug in your y everywhere you see it. So there's a y right there, -2 times -1, that would just simply be +2. And so this first equation becomes x plus 2 plus 6 is equal to 9, in which case you could rewrite that as x plus 8 is equal to 9, subtract 8 from both sides, and you would be getting here x is equal to 1, okay? So this actually turns out to be a really easy linear system involving multiple variables, because we just go ahead and do this, right? This back substitution. We took our z, we substituted back into the second equation, we were able to solve that second equation for y, we were able to take both of those values, substitute it back into the first equation, and again, we were able to get all these nice values here, okay? And so it turns out that this form that this was originally written in is so handy, because it was so easy to solve, that we actually give this a name. And this is a big fancy name for basically just a multivariable system that is already nice and easy to solve, looking just like this. We actually call this row echelon form. Okay, and again, there's no need to worry about, you know, exactly why we call it that. It's just the name that we give a multivariable system that has this form, basically where one of your variables is already solved for, and you just have to back substitute to get the other two variables. Okay, so that is such an important form, and that makes a system so easy to solve that we point it out, we give it that name, and so our goal whenever we solve a multivariable system is to rewrite it so that it is in this row echelon form, because then, as we just saw, it's nice and easy to solve, okay? So what that is going to involve is doing this whole method of what's called Gaussian elimination. And this is after the mathematician whose last name was Gauss. He's one of the most famous mathematicians of all time. Very, very important dude in the world of mathematics. We go ahead and we honor him today by naming this method after him. And basically, it's just a way for us to end up with a row echelon multivariable system, okay? And there are a bunch of different ways that you could go ahead and do that algebraically. You can switch the equations, the order that they're written down on the page. You can multiply one of your equations times some number and then add it to another equation that you have, just like we saw in the last video whenever we talked about elimination in the last video. Now, while all this is relatively simple to do algebraically, I'm not going to actually demonstrate any of that in this video. What I want this video to actually be is how to basically use the calculator to do all of this work for you, okay? So primarily, I'm going to show you how to do this stuff in the TI-84, which means that if you don't have a TI-84, you might have to download that free emulator to your student device in order to go ahead and get this taken care of here, but I'd like to go ahead and demonstrate how you can use the TI-84 to basically solve equations or multivariable systems that look exactly like this. So feel free to send me a quick message if you don't have the emulator on your device, and we'll find a way to get it there. or we'll find an alternative for you, okay? But let's go ahead and take a look at example 1 here. So I'm going to show you how to use the TI-84 in order to go ahead and do this. I also have left a handout in your Schoology page for today that is going to basically demonstrate this exact same process to you, okay? So let's go ahead and take a look at what we've got, right? We've got this multivariable system. This does not look like row echelon form, does not look like it would be something that's nice and easy to solve. So again, we could do some Gaussian elimination here. We could go ahead and maybe multiply one of my equations times some number and then add it to the third equation to try to eliminate a variable. And you know, we could also reverse the directions of the order that we've written these equations in. We could do all that mess, or we could just let the TI-84 do it for us here. So here is how that is done. You pull up your TI-84, okay, and we're going to type in what you call a matrix, okay? So in order to go ahead and type that in, you're going to press on the TI-84 the second button, and then you're going to go down 1, 2, 3 buttons there to where it says x to the negative 1. You'll see in the corner of that button it says matrix. We're going to press that button after pressing the second, and this is basically your matrix menu. So throughout the video, if I say go back to your matrix menu, that's what I mean, is press second x to the negative 1 button, and it's going to take you to this menu right here, okay? The first column there basically just says names. It just is giving you names of all the different matrices that you have stored in your calculator. We don't have any stored here, as you can see, so let's go ahead and arrow over to edit, and that's just using your left and right arrow buttons to arrow over to the edit tab. And then I'm just going to go to number 1, the matrix named A. I'm going to press enter to pull that up, and it's going to bring up this little screen right here. And the first thing it's going to ask you to type in are what are the dimensions of your matrix. Okay, so let's go back to our example here, and let's point this out, right? So we basically have a multivariable system here that has a row consisting of 1, 2, 3, 4 numbers in it, okay? So what I might do on the page is I might just simply go ahead and write out all the coefficients of that first row, okay? So that was a 1x, so I'm going to write down a 1, and then it said negative 2y, so I'm going to continue with negative 2, and then positive 3 for z, and then on the other side of the equal sign, there is 9. So I'm going to basically write that as a row in the matrix in my calculator. 1, negative 2, 3, and 9. Okay? Now, what I'm obviously going to need for that is I'm going to have 1, 2, 3, 4 columns, and you can see here that I have 1, 2, 3 rows because I've got 3 equations. And so for that reason, I'm going to have to go ahead and type this in as a 3 by 4 matrix. And you can see there that as you were to go ahead and type that in, I just typed in 3, arrowed over, typed in 4, and press enter. It automatically gives you the shape. So if you accidentally reverse the roles there, you could just easily arrow back up and change those values and get the right matrix going on here. But we want a 3 by 4, and we know what the numbers in our first column need to look like: 1, negative 2, 3, and 9. So as you type these in, I'm just going to press this in, positive 1. I'm going to press enter to solidify that entry, okay? So type in your number, press enter, okay? So negative 2, enter, 3, enter, 9, enter, and you can see that it brings my cursor back down to the first entry of the second row, okay? And we just need to think a little bit about what the coefficients would look like there. Well, I have a negative in front of this x, so that would be a negative 1 to start, so negative 1. And then after that, I've got a positive 3 coming next, so that would be 3. After that, you don't see anything for z here, but the interpretation, of course, would be that I have 0z, so I do need to type in an entry for that. It turns out that that's just the default entry in the calculator is to put a 0 there, so we could just go ahead and skip that one in the calculator. And then finally, of course, you see here I've got a negative 4 going on, okay? So that's going to be my next row: negative 1, 3, 0, and negative 4, okay? So negative 1, enter, 3, enter, 0, enter, 4, enter. Okay, oops, I needed a negative 4. So let me go ahead and use my arrow buttons to arrow back over there, type in negative 4, just right on top of it, press enter, it'll automatically change it, we're good to go, okay? So there's no need to like clear the entry out by pressing clear or delete or anything, you just type right over the top of it, okay? And then finally, we do need that last row there, so again, we're gonna look at all the coefficients here. Again, you'll notice that I'm also paying attention to the signs in front of my numbers. That is gonna be incredibly, incredibly important for the calculator to be able to do our work for us here. So 2, negative 5, positive 5, and then positive 17 here, okay? So you can see here that there's a lot of thinking going on. There's a lot of typing into the calculator going on here, so just be very, very careful as you type these values in, because, again, if you get one of these incorrect, unfortunately, you're not going to be able to get the right answer, okay? So let's go ahead and carefully type that in. So 2, enter, negative 5, enter, 5, enter, and then 17, enter. Okay. Again, always just take a step back and look at what you typed in. Make sure that that is identical to what you have written on the page here. And what we've just written here, again, maybe pays to go ahead and write down what we just did, right? This is called a matrix. And you might have seen these on stuff like the ACT and that kind of thing, but basically what a matrix is it's just an array of numbers. It's an arrangement of numbers in this order with rows and columns, and it can be used for a wider range of different things, right? So here it's modeling a multivariable system. In other contexts, you can use matrices to store data in a computer. It's kind of the way computers think. If you think about it that way, you can define vectors in higher level mathematics or in physics by using a matrix. There's a lot of really handy ways of being able to use matrices, but here we're using them to solve multivariable systems, so let's go ahead and continue, right? So back to the calculator, we have our matrix typed in, everything's all good to go. So what we can go ahead and do now is just go ahead and quit out of this matrix entry screen here, right? And the way we do that simply is just by pressing second, and then the button right to the right of it. It says mode, you can see it says quit in the corner there, so that's just going to allow us to quit out of that screen, and we're going to get back to our calculation screen, okay? If you were to go back to your matrix menu, again, second x to the negative 1 button, you'll now notice that because we typed something in for matrix A, it automatically puts the dimensions of what we just typed in next to it so that you can always remember what matrices you've typed into and which ones you haven't, okay? And so if we go ahead and press enter, we can go ahead and press enter again, and it will pop up with the exact matrix that we were working with. So that's good. So that's locked in. We're good to go. The next thing that we want to do is we want to go ahead and convert this matrix to its row echelon form. So R, row, E, echelon, F form. So in the calculator, there is an REF function, or a row echelon form function, and you can find it by going to your matrix menu, second x to the negative 1 button. You need to arrow over to one tab that says math here, and then it just brings up a bunch of things that you can do mathematically with matrices after you type them in. We want one that's actually towards the end of this list, so you could use your arrow down button in order to get to it, but I'm actually going to press my arrow up button because it's automatically going to loop me back around to the bottom of the list. And then what we want, of course, is you can see it. There it is right there. It says REF, that's row echelon form. We're going to press enter to pull it up, and then we want to go ahead and do row echelon form of the matrix A. So we're going to go back to our matrix screen, second negative 1 button, and then we're going to go ahead and press enter to pull up our matrix A, and then press enter to actually execute that, and you can see here that that puts it into our row echelon form for us. So that is the form that we saw in the very first multivariable system that we had today. So we would just need to be able to interpret that, right? So if you look at that very bottom row, it says 0, 0, 1, 2. That would be 0x plus 0y plus 1z is equal to 2. Okay, so we are interpreting this as the numbers that are in the rightmost column. Those are the numbers that come after the equal sign. And so that very last row, again, we basically just read that as z is equal to 2. Okay, and that's exactly what we had in the multivariable system that we had before this one. Okay. As a matter of fact, if you didn't pick up on this, this is actually identical to, actually, I guess it's not identical. I guess I need to pick up on this, don't I? I thought that that might have been the one that we just looked at here, but I guess it's apparently not, right? And then you could basically just kind of draw the similarities to our example here and the example that we took care of with back substitution before. If it's in row echelon form, it's nice and easy to solve from here. But I've never been in the business of lying to you all. We can actually make the calculator do one better for us here, okay? We can get a what's called reduced row echelon form going on. And we could do that by doing some very similar steps to what we just did. So if we go back to the matrix menu, second x to the negative 1 button, we're going to arrow over to our math tab. I'm going to go towards the bottom of my list. I'm just going to press the up arrow button to get there quickly. And you can see there right below the one we just did, it says RREF. Again, that stands for row reduced echelon form. Press enter to pull it up. And then you can go ahead and just go back to your matrix menu. In the names tab, just press enter on matrix A because that's the one we typed into, and then press enter. And if you go ahead and interpret that in the way that we just did for your row echelon form, you could see here that basically this is what we really, really want. This is going to have x solved for, y solved for, and z solved for, okay? And so I'm going to go ahead and write that down in our notes here. Okay, so if I come back here to our example, we did the row reduced echelon form, and we were told that that is going to be the following. And I automatically know that these entries are going to be these because this is what row reduced echelon form is always going to look like. And again, the way that we interpret that is that this last column of numbers is always going to be the column of numbers that comes after the equal sign. What we see in the calculator here is that's going to be 1, -1, and +2. So how in the world are we supposed to interpret this? Well, keep in mind that these are all the coefficients on your variables. The way that you would interpret this, of course, if you look at that first row, is in the following way. You would interpret that as 1x plus 0y plus 0z is equal to 1. Or in other words, x is simply just equal to 1. That's not too bad, okay? Second row down, 0x plus 1y plus 0z is equal to -1. So interpreting that, it's going to be y is equal to -1. And then finally, your very last row, so 0x plus 0y plus 1z, that is equal to 2. Okay, so nothing you can't reach the conclusion of by doing your reduced echelon form, but row reduced echelon form is much more preferable for just being able to get your answers nice and easily, okay? And so that would be a complete problem there. Again, it could be one of those things where you look up some other online resources for how to actually algebraically do the Gaussian elimination, but it's a little bit quicker to go ahead and type it in as a matrix in your calculator and then be able to do the row reduced echelon function of your calculator, okay? The next examples I've already gone ahead and done for you here. You'll notice that I've just gone ahead and put a little bit of a line separating the first 3 columns from the 4th column, because remember that line is where our equal sign is. And so basically interpreting that in the context of the problem, we would see that x, y, and z are all completely solved for. X is equal to -1, y is equal to 0, z is equal to 4. Next example I already did for you again just to kind of save time, and I wanted to show you this because this is an example of one multivariable system that actually doesn't have any solutions. If you were to try to type it in and do your row reduced echelon form, then what you're going to end up with is something that looks like here in the middle, right? So it's not the case that these values here actually ended up being zeros. They actually ended up being something else. And so if you were to interpret that back into the context of your multivariable system, you might have something like this, which is actually a set of equations that you're not going to be able to solve, right? You don't have a value of z or y or x that you could back substitute into these other equations to get your 3 values. So again, the basic moral of the story is that when you do this in the calculator, your row reduced echelon form, you are really looking for this. You're looking for a diagonal of 1s and then everything else to be a 0 in these columns. That is row reduced echelon form right there. So if it doesn't say that, you know that you're going to have a system like this one in example 3 that doesn't have a solution. And the very final example that I want to take care of in this video is actually a word problem where we're actually modeling a real-world situation using a multivariable system and then using the calculator to go ahead and solve it. So it says here, during the second game of the 2002, as normal people would read that, Western Conference Finals, the LA Lakers scored a total of 90 points, it's going to be important, resulting from a combination of 3-pointers, 2-pointers, and 1-pointers, okay? So here's the thing. We don't know how many of each of these 3 types of goals were scored, so I'm going to give them names. So let's let x be the number of 3-pointers, let's let y be the number of 2-pointers, and let's let z be the number of 3-pointers, okay? It says here in the next sentence, there were 11 times as many 2-point baskets as 3-point baskets. Pause there, right? So if I were to interpret that statement, we just said that y represents the number of 2-point baskets. It says here that there were 11 times as many 2-point baskets as 3-point baskets. So that means that the number of 2-point baskets, which we called y, there should be 11 times that amount of, what did it say? 3-point baskets. So that'll be 11 times x. Okay, you can see there I've already got my screenshot of the calculator ready to go. But again, there we go. So y equals 11x is going to model that statement, that there were 11 times as many 2-pointers as 3-pointers. If I were to go ahead and write that in the form that we would prefer to go ahead and put it into our multivariable system later, I'm just going to subtract 11x from both sides. So minus 11x, and you would have the following. You would have negative 11x plus 1y plus 0z. I'm I'm just going to go ahead and write that, is equal to 0. We're going to hold on to that equation for later, so I'm going to make sure that we don't forget it. I'm going to highlight it here. There we go. Okay, so we've got that. Continuing to read, it says, then there were 5 times as many free throws as 3-point baskets, okay? Free throws, I'm not a sports guy, but I'm going to interpret that as a 1-point goal. And so let's go and interpret that in this way, right? So there were 5 times as many free throws as 3-point baskets. So the number of 1-pointers is Z. Apparently that is equal to 5 times the number of 3-point baskets, or in other words, 5x. So if you were to go ahead and rewrite that in the exact same way that we rewrote the other one, you would have the following. It would be negative 5x plus 0y, because we're missing our y here, plus 1z is equal to 0, okay? So that's another equation that we got, all right? And then it says, what combination of scoring accounted for the Lakers' 90 points? Well, if the total of all 3 of these were 90, then we can go ahead and set that up in this way. We could say that there were 3 points for each of those 3-pointers. There were 2 points for each of those 2-pointers, and of course 1 point for each of those 1-pointers, all totaling up to 90 points, okay? And that is going to be our third and final equation. So our multivariable system, if we put everything together, is going to look like the following here, okay? It's going to look like that first equation there, followed by our next one. So that would be negative 11x plus 1y plus 0z is equal to 0. And then follow that up with our next equation from over here. So that's a negative 5x plus 0y plus 1z is equal to 0, okay? And there is our system right there. And we can now just go ahead and plug in all of the coefficients of our system into the calculator as a matrix, and it will do all the work for us if we do your row reduced echelon form, okay? And of course, I've already got that ready to go over here. So you see me typing in my matrix there. Now you notice that the order is not something that really matters here, right? So the way that I wrote it out by hand was that I had the equation with x having a coefficient of negative 11 first, but you'll notice in the calculator that I basically swapped these 2 rows, and that doesn't matter at all. Basically, the order of each one of these is not so important, but the coefficients as you go from one entry to the next, that is very important here, okay? And you can see here that I already did your row reduced echelon form. So again, if we were to interpret this, that would simply be 1x plus 0y plus 0z is equal to 33, or in other words, we might interpret that as x being equal to 3. We might interpret this as y being equal to 33. And finally, z being equal to 15. So while the calculator will do all this heavy lifting for you, it is important that you go ahead and make sure that you understand the interpretation of what your calculator is telling you, okay? And so, of course, we can go ahead and interpret that as there were 3 3-pointers, there were 33 2-pointers, and there were 15 1-pointers. And that is going to complete the problem right there. So you can see here, if we go ahead and rely on the TI-84 to do all this heavy lifting for us, these are not too bad at all. In the case of that last example, you do have to do a little bit of modeling of the situation with your multivariable systems, but other than that, it's just using the calculator after that. So make sure to check out that handout that I've left in your Schoology folder for today. It's going to go ahead and basically re-describe all of those same steps in the calculator for you. But that's all I have for this one. Thank you very much for your attention, and I'll speak to you guys in the next one.